Good evening, ladies and gentlemen. Tonight we're hooking up a single phase to three-phase inverter for this Chinese motor here for the milling machine. It's a little vertical horizontal unit. This is for the vertical spindle. This is a 6-lead motor. It could be hooked up in either delta or Y. In this particular installation, I'm hooking it up in the Y configuration. Nothing special. This is a very, very inexpensive Chinese VFD. I bought it last year before the COVID thing happened, and this was very, very inexpensive. This is a 3-horsepower drive. The motor is only a single horsepower motor, just 1 horse, so it will have absolutely no problem driving it. It's not even going to pull a third of the current that this thing is rated for. So yeah, it's I guess what you'd call overkill for what it's going to be doing, but all I really want it for in the first place is taking single-phase power and making 3-phase power out of it. I just got the added bonus of being able to vary the frequency, and thus I'm not going to have to change the belt positions very much. Yeah, it'll make a very, very nice power interface. So without much further ado, this has been programmed already. There was only just a few program parameters that I had to change over on it. This is not a top-end drive, so there are not a lot of extra features that most people won't use anyways, but this does provide the basic function. So without further ado here, we're set to 60 hertz right now, but this is fully adjustable between, I set it all the way down to 15 hertz, but it doesn't actually operate on 15 hertz. So 20 hertz, about 22 hertz is about the lowest end on this thing, which I probably won't run it that low anyways. But on the high end of it, I'm up to 90 hertz. So this motor, when it comes from China, is basically running on 50 hertz. We plug it into our 60 hertz, and it does increase the speed just a little bit for the U.S. market. It's not a big deal. It's basically what is it, 10% or whatever. So this is going to be the 60 hertz baseline. Let's go ahead and run this thing. As you can hear, the motor purrs like a kitten. Very nice cooling. Okay, so let's go down first. So right now we're at 48 hertz. You just barely start to hear the carrier whine. You may be able to hear it better on camera. But even as we reduce it, the carrier frequency is set that it does not make a lot of noise. Now, I bumped the carrier frequency all the way up to maximum on this thing. Probably should have a high carrier frequency, otherwise you're going to get a lot of electronic noise. Okay, so this is at 19 hertz. It's probably doesn't have a lot of power at 19 hertz, so I wouldn't plan on using it this low. This is just a demonstration. So let's go ahead and that's half of normal. So that's pretty much normal, like it would be plugged into the wall. Now this is single phase, powering a 3-phase motor through this box for the uninitiated. Okay, right there, it's a little over 70 hertz. The motor has no problem with that. Almost 80 hertz, no problem. 85 hertz almost, and purrs like a kitten. Now I got the maximum set at 90 hertz. Technically I could probably go to 120 hertz without much of a problem. But what happens at 90 hertz is you're really exciting the windings inside of this thing. There's enough airflow where it'd probably keep it cool, but the motor will get hot on double the speed, basically. And really, there's no need. We still are retaining the different pulleys, so there is still going to be speed change. You know, I just won't have to do it as often. But it sure is nice to not have to drag a three-phase line in and get three-phase power to power a motor. This will go on the milling machine, and once I'm done with the milling machine, I'll go ahead and make another video and let you guys hear it on the machine. Actually, this is just getting all the ducks in a row before I start retrofitting. Anyways, thanks for watching.